Welcome everybody to our explanation video about our recent IP results, which we collected in January, just to the west of the Mckinnon Zone. So what I'm going to do to put these conclusions into context for you, I'm going to talk a little bit about what IP actually is, how we use it to find gold, and what we've seen at the Mckinnon Zone to help us understand what we've now seen to the west of the Mckinnon Zone. So IP, or induced polarization, is a type of geophysical survey, and it's another tool we have in our toolbox to start identifying drill targets. Now, why we do this instead of just going straight to drilling is because drilling is very expensive. It's about $250 a meter, which when you're thinking of a 400-meter hole, that's $100,000. Now, $100,000 conversely can get you quite a number of IP surveys or a pretty large airborne survey. And since a drill core is about 5 centimeters wide, 2 inches wide, and our property is very large, 80 kilometers long or 540 square kilometers, you're really looking at a needle in a haystack there. And so when we go to drill and spend those drilling dollars, we want to do it as efficiently as possible. So we try to collect this lower cost data first. And we layer, but each of those tools that we use, each of those geophysical tools, geochemical tools, they each tell us something about the rocks, but then they also have their limitations. And so what we do is we take each of those data sets, layer them on top of each other, and see what pattern starts to emerge. And the benefit of the Hawkins project is that we have the Mckinnon Zone. And so we can not only use that Mckinnon Zone to see if that Mckinnon Zone can become the deposit, but we can also use it as a case study for where gold is located on the property and what patterns in that data gold is associated with. So Mckinnon Zone, since we already know there is gold there and we know how much is there, we can use it as a baseline for the patterns of gold mineralization that's associated with other tools and start to emanate away from the Mckinnon Zone and use that to explore targets on the rest of the property. So what we're looking at here is a map that anyone who's been following the story is very familiar with. We're looking at the central 15 kilometers of the property here. This is a bird's eye view down on top of the earth. We can see the Mckinnon Zone 3.5 kilometers long in red right here. And this is sitting on top of another type of geophysics survey that we've been using, which is airborne magnetics. Airborne magnetics is collected when you fly a plane over an area, so you can get a very large area of data. And it just reads the magnetic signals from the rock. And so what we have seen here at the Mckinnon Zone is this low magnetic signal in blue with the moderate in green. And you can see that that is quite associated with the Mckinnon Zone. And what that does is allow us to say, well, interesting, we see this signal moving to the west, and it also is associated with these high-grade prospects. So now we're interested in this area also. So what we ended up doing was collecting the new IP survey over here to the west of the Mckinnon Zone. So IP, as I said, induced polarization, reads a different signal than the magnetics. Of course, airborne magnetics reads magnetics, but IP reads chargeability and conductivity, or inversely resistivity. So if something's very conductive, it's low resistive. If it's very resistive, it's low conductivity. And I'll explain those concepts in a minute. So here we see an IP setup. Airborne magnetics is collected with a plane, whereas IP, you cut these line kilometers down and you lay out these wires here. And at one end, you send out a current into the ground, and that at each of these posts, these are receptors, they will see what happens to the current as it moves through the rock. So chargeability is the first thing that IP reads, and it basically tells you the presence of material that's excitable by electric currents. So metals, water. So when something's chargeable, then it's excitable by these currents. Then conductivity, or the converse of that is resistivity, tells you how well that current can move through the material. If chargeable material is very connected, then, such as in this case here, then that current can move through relatively easily. But if the chargeable material are in discrete pockets, it's going to be harder for that material to move through. So this is going to be resistive material, but high chargeability. And this is the case at Mckinnon. Some resistive material is often quartz. So you see quartz often associated with gold mineralization because quartz indicates fluid movement through rocks. So often with gold deposits, and it is is the case at Mckinnon, you'll see very resistive material because the current can't move through, but chargeable highs, high chargeability, because you do have excitable material there. So flipping forward to what we see at Mckinnon, as I just mentioned, now we're zooming in a little bit. We're still looking at a bird's eye view at the surface of the Earth. We've got the Mckinnon Zone right in the center of this, right in the center along my mouse here. We've got the IP survey now in the back. This is no longer the magnetics, this is the IP. And you can see these reds and purples really are the highs, the chargeability highs. And you can see that chargeability high is not exactly, it's not 100% correlated with the Mckinnon zone, but it's relatively associated with the Mckinnon zone. Okay, so now what did we do to the west here? So we're stepping back again, bird's eye view down at the surface of the Earth. But now what we have is the central 15 kilometers with that airborne magnetic survey. We've got the Mckinnon zone right here. And to the west in this red block is our IP survey area. And what did we learn from that? Well, what we saw were these black lines, which are associated with IP anomalies. Anomalies mean signals that we're interested in. And importantly, we can see especially these two here that really follow along strike of the Mckinnon zone. So now when we're talking and thinking about layering our data and seeing patterns, what we're seeing is a magnetic signal that trends west. We're seeing an IP signal that trends west, and it's along the Mckinnon zone. And so now we're very interested in exploring this area. And the next steps, the next data to layer when we're trying to figure out our drill targets is going to be sending mappers, our geologists out there to do some mapping and prospecting and trenching to confirm geologically, do we see the same rock type, and to collect structural data. And especially that structural data will help us figure out where we want to drill. Because remember, this is a very large area. A drill core is about 5 centimeters wide. We want to be a little more specific in our drill targets. All right, well, thanks for watching this video. Thanks for watching this explanation. We're very excited about all of the activities going on at the Hawkins Project. If you want to keep following us and get more news updates, subscribe to our mailing list, follow us on Twitter, Facebook, LinkedIn. You can also give us a call. We're happy to set up meetings and answer any questions you might have about the project. Thanks.